Hey, this is Ralph, and this is going to be one of our first lectures here for 235. And I want to go over some Excel stuff. And what I want to do here is demonstrate a bunch of different things that you're going to want to do in Excel for your first quiz coming up. And there's lots of individual videos on these skills, so you're going to want to go back and review the skills that are most challenging for you. But I just want to do a quick overview and demonstration of everything, and this would be pretty much what we would do in class if we were doing a face-to-face class. So you're going to want to have Excel open, and you're going to pause regularly. If you've got a dual monitor system, that'd be fantastic. You could kind of watch this, lecture in one screen, and then you could work on another. But you can still, by pausing and jumping back and forth and things like that, you can work pretty well. If you don't have a dual monitor system, I'm not going to say it's a necessity, but it's not that tough to do. Even if you have a notebook computer, you can easily attach a second monitor to it. That's pretty nice. Or certainly if you have a desktop, dual monitor system is pretty easy. If there was room in the lab, and there's usually not, you could actually log into two computers side by side and kind of work that way, but it's tough to find two computers in the lab. But anyway, so let's get started here. So I've got Excel open, and I'm going to go ahead and do a little bit of experimentation on some different things. Before I get too far, though, I will go ahead and save what I've got. And when you save your work, be organized. Okay, so I've already got a classes folder here in my documents, and I put a little underscore so it's always alphabetized at the top. And I've got my 235 folder in here somewhere. There we go. And I've even got a demo files folder. So you would just keep all of your work organized. And I'm going to call this finances overview. There we go. I think Excel is a great program, and you want to get really good at it. And you're not going to use Excel just in this class, but you'll certainly used it certainly in CIS 120, used it quite a bit in CIS 131. You'll use it here. Some of you are going to be taking CIS 125E, which is 10 weeks of Excel. So you should get really good at it because it's one of those great programs where it can be used by individuals, small businesses, and large businesses. For doing a bunch of different things, but generally for managing data, especially numeric data. That's where it really comes into play. Sure, I know in 120 you can sum numbers up and you can make charts, pie charts and stuff like that. But we want to go a little bit further in how we might solve some business decisions using Excel. I'm going to use some personal finance scenarios though, because I think if you can solve some personal finance decisions using Excel, then it's going to make it easier for you to translate this over to a business. Plus, it's going to give you a lot of reason to practice with Excel, and that's really what I want you to do, is practice a lot. The first thing I want to do is go over the payment function. I'm pretty sure they do payment function very briefly in CIS 120, so it shouldn't be unfamiliar to you. And I like it because it's one that we could all use and to figure out monthly payments for things. I'm going to do a little bit of setup here. I'm going to start off, and I'm going to go ahead and put in something like item price, and I'll put in down payment, loan amount. And let's see, I'm going to have in, I'll put the month in loan, or the terms in loans. So number of months and interest rate, monthly payment, and I'll put in a cost of financing and total cost. So I've got all of these categories here, and this is basically just a bit of setup. And the item price, it could be a car, it could be a house, it could be a boat, it could be anything that you would buy that you would finance. For a business, it could be a building, or it could be some land or things like that. And let's see, I'd actually like to move all of these down a bit here, so I'm just selecting everything. I'll just click and drag on my border once. And I'm going to do, I think, a few different scenarios just so we can really get a good overview. And this first thing, this is going to be for a, I'll do house, let's see, house 1, okay? So, and once we do the first one, all the others are going to be really easy. So let's see, house 1, I'll go ahead and put down $60,000. The down payment, I'm going to make that a formula. I'll take the price of the house, multiply it by 0.20 for a 20% down payment. The loan amount, let's see, is going to be equal to the price of the item minus the down payment. Now notice I'm using cell references quite a bit, okay? And you want to use cell references as much as possible because it's going to make it easier for you to do what-if scenarios. So when possible, use a cell reference. The only time you wouldn't use a cell reference if you know for a fact that the number is not going to change. So my loan amount, how much I need to borrow, is going to be the item price minus the down payment. So if I want to buy a $10,000 car and I put $4,000 down as a down payment, that means I'm going to have to borrow $6,000 to make up that price difference, okay? So I'm taking my loan amount minus, my item price minus my down payment to figure out how much I need to borrow in order to pay for the whole thing. In this case, 128 grand. Now, expressing a house loan in number of months is not really realistic. Generally, you'll get a, maybe like a 30-year mortgage or something like that. I'm going to go ahead and assume a 15-year mortgage, okay? A 15-year mortgage in the term of months is 180 months. And the interest rate, I'm going to go ahead and put down, let's put down 4.6%. There we go. Good low interest rates. Now I want to figure out the monthly payment, cost of financing, total cost. So basically, so far I've been providing Excel some information. Now I'm going to have Excel give me an answer based on what I've provided. So I'm going to use the monthly payment function. In your previous use of Excel, you probably went into the paste function dialog box, which is fantastic. And of course, you could find the payment function. Do a search for it, and there it is, PMT. Calculates the payment for a loan based on constant payments and a constant interest rate. So this wouldn't be the exact same procedure if this was a variable rate loan. Okay, so if it's a variable rate mortgage where the rate changes yearly or every few years, there'd be a different procedure we'd want to go for. But if this is a fixed rate loan, and most car loans and house loans are fixed rate loans, this is a fine way to go. So the payment function, if I start up that payment function, I simply provide the information for each of the parameters. My rate, I don't want to type in 4.6%. I'm going to click on the cell that contains my annual interest rate. But because this is a monthly loan, I need to take that annual interest rate and divide it by 12. Now it'll give me a monthly version of my annual interest rate, hence my monthly rate. The number of periods in questions are the number of payment periods. Now, since my payment periods, basically how many payments will I make over the life of the loan, since it's already in terms of months, I can just click on the cell that contains the number of months. Now, the present value is my loan amount, okay? And so I'm going to click on the cell that contains my loan amount. And then I'll click OK. There we go. And this is my monthly payment. And the monthly payment for my house is just under $1,000. Now notice it's red in parentheses. Excel is telling me that's a negative, and that is actually accurate. When you're working with accounting and finance, money that leaves you is a cash outflow and is expressed as a negative. Money that you take in is a positive. That's a cash inflow. Well, the $128,000 that I borrowed, that's technically a cash inflow. Somebody gave me that money, so now I have to pay it back. So the inflow is expressed as a positive, and the outflow is expressed as a negative. Let me go ahead and put all of these in currency formatting just so they have a consistent look to them. There we go. So let me get rid of the decimals. So I just changed the formatting for my numbers a little bit. So my negatives here are still shown with parentheses. That's actually more common than showing the little minus sign. People in finance or accounting will rarely use the little minus sign to show a negative because it's hard to miss. So parentheses is a common way to show a negative number, and I've just taken away the change. So now the numbers are displaying just the dollar amounts, the dollar values. Okay, so basically I'm going to have to pay $986 per month to pay off this house over 15 years, assuming I bought a $160,000 house, paid $32,000 as a down payment, and borrowed $128,000. Okay, now the cost of financing is going to be how much you had to pay extra. What does that really mean? Well, if I paid cash for the house, meaning I didn't borrow any money, then it's, you've heard the expression, same as cash. Well, then you would just pay 160 grand. But because I borrowed money, I actually end up having to pay more than $160,000. So it would actually be good to figure out my total cost before I figure out my cost of financing. No problem. I could simply take this cell, move it down below total cost, take these two cells, move them up, and now they're reversed. So now I'm going to figure out total cost first. My total cost is every payment I had to make. Okay, so that's how you have to think about it. So check this out. If I type in a regular formula and I take my monthly payment and I multiply it 180 times. Okay, so basically for this house I had to pay $986 and I had to do it 180 times. Okay, I'm not done yet, but I'm going to press enter anyway. There we go. $177,000. So the house cost $160,000, but if I add up all my payments, I had to pay $177,000. But wait, there's actually more. Don't forget, I also paid that $32,000. Okay? So my total cost is really more than $177,000. So I need to modify this formula. Now this is weird because obviously this product is resulting in a negative. Let me just go and wrap those in parentheses real quick. There we go. So I have a couple choices. I know this is a negative number. Negative times a positive is a negative. I could subtract my down payment and I would get the bigger negative. Okay? Or I could do it like this. I could do a plus the negative. Okay, still get the same total. Like, wow, that seems really weird and tricky. And maybe it is. I like the logic of this a little bit just because it kind of it makes more sense to me, because I can say, all right, well, this is the total of my monthly payments plus my down payment. Okay, so those two costs together are how I get to my total cost of $209,000. Now that I know that my total cost is $209,000, I can easily figure out the cost of financing. So to figure out the cost of financing, I just have to figure out, well, if I paid $209,000 for the thing, in this case a house, and if I paid with a big chunk of cash, I could have just paid $160,000. Well, the difference is going to be the cost of financing. Now, it's a little bit weird just because we have a big negative number for our total cost, and we have a big positive number for our item price, so we don't just want to do a normal subtraction. So I'm going to do a little bit of a Excel function here. I'm going to take the absolute value of my total cost, and I'm just going to subtract the original price of the item. Okay, so the absolute value of my total cost minus my item price, and that's going to result with just about 50 grand. Let me go ahead and take the decimals off of this. There we go. So now we've got some information. Align that to the right. Bold. Okay. So here's what we've got. This house is $160,000. I made a 20% down payment and had financed the rest for 15 years. Oh, my interest rate isn't displaying properly, even though it's still in there accurately. Let me just change this back over to a percentage, and I will show decimals there. There we go. So I want that interest rate to stay a percentage. So financing for I'm financing the rest, $128,000 at 15 years at 4.6%. My house payment is going to be just under $1,000, $986. Now, over the 15 years, I will have ended up paying about $209,000 for this $160,000 house. Obviously, I've got the house for 160, and then I had to pay an extra 50 grand, 49,434, just in finance costs, finance charges. So that's how we can use Excel to get some information about a fixed loan, and a mortgage is a fixed loan, really common one. Now, let's go through a couple other little scenarios here. This is going to be really slick. I'll just be able to take all of this and drag it over to the right, and now I've got different house scenarios. Let me just expand those a bit, a little wider. There we go. And let's see what we've got here. Some of these numbers look really wacky, but I'm going to change this out. House 2 is going to be 200,000. That's pretty good. And I'll change this over to car 1 and car 2. Car 1 is going to be 30,000 and car 2 will be 15,000. Okay, and let me just go ahead and fix up some of this. House 2, $200,000. There we go. The number of months, though, I'm going to do this over 360 months, which is 30 years. There we go. And the interest rate, 104%, is pretty steep, so let's not pay that much. But since it's a 30-year, let's change this up to maybe like 4.9%. Okay. And let's kind of focus on these first two houses for a second. Okay, so we already know about house 1, 160 grand. House number 2 is $200,000. And look at the payment. House 2, the more expensive house, is going to have a smaller monthly payment because I'm financing it for twice as long, 360 months. And technically these really shouldn't be currencies. Let me just change this to number style. Get rid of the decimals. There we go. So 360 months, twice as long, gives me a slightly smaller payment. But look, check this out. Cost of financing, instead of $50,000, almost $150,000. So house 2, I'm going to have to spend almost $150,000 extra just because I'm financing it over a longer time. And yeah, the house is more expensive, but check this out. If I change house 1 to $200,000, there we go. Equal houses, equal prices, same down payment, same loan. However, one loan is financed for 15 years, the other loan is financed for 30 years. 15-year loan gets better interest rate. Now the 15-year payment is going to be a little bit higher than the 30-year payment, but of course the big savings is in that cost of financing. Now for my cars, let's see, I've got a $30,000 car. Let me just go ahead and format these a little bit, slightly different color. I've got a $30,000 car and a $15,000 car. I'm still making a 20% down payment, so I'll have to finance the rest. Now for car loans, that's a little bit steep there. So I'm going to say, how about 48 months for the first car, and let's do just 24 months for car 2. The interest rate, let's knock those up a little bit. How about car 1 at 48 months? Let's go ahead and make that 6.9%. And car 2, let's make that 5.9%. Let's do 4.9. All right, there we go. So the car payments are pretty similar here, actually, even though car 1 is costs twice as much. But it's financed for twice as long, and that's why that's the effect of the payments there. The total cost for car 1 is over $33,000. Total cost for car 2 is almost $16,000. And here we go, the cost of financing. The cost of financing for car 1 is $3,500. For car 2 is $622, which means the longer we finance something, the more the cost of financing is, because you generally pay higher interest rates, and you're paying those interest rates for a longer period of time. Now let's do a little bit of goal seek. Now let's say I want car 2 here. It's $15,000, but I don't want to pay $526 a month. I only want to pay $450 a month. So I'm going to have to make a bigger down payment. So I want to use a tool called Goal Seek. Now in order to use Goal Seek, The cell that you are seeking information from needs to be a fixed number, not a formula. Well, in this goal, and my goal is to find out how much down payment do I need, okay? In fact, I'll do this. There we go. How much down payment is necessary to get the monthly payment down to $450? So the monthly payment for this car is currently $526. I want it to be $450. So I'm going to have to manipulate my monthly payment. And I could just start trying out different numbers. 4,000, closer. 5,000, too far. So I know it's somewhere between 4,000 and 5,000. So my goal is a $450 monthly payment, and I need to know the exact down payment to get to that. Well, I could keep doing trial and error here, but it would actually be better, let me just move that a little bit closer, be better if I just used goal seek. So in Excel, I'm going to go to the data menu, what if analysis, and goal seek. I'm going to bring up this little dialog box here. I'm going to set the cell that contains my monthly payment to a negative 450 because that's the monthly payment that I want, 450. And I'm going to get that by changing the cell that contains my down payment. And I'll click OK. And it's determined, I'll click OK. It's determined that I need to put down $47.32 as a down payment in order to get that $450 monthly payment. So very, very useful trick there. Goal seek. Let's try this again. Let's use our house though. Okay. How much down payment is necessary to get the monthly payment? Let's see. I'm going to change this over to 180 months. 15-year mortgage is a little bit better, I think. And to get the monthly payment to exactly $1,190. Maybe I've determined that's the monthly payment that I want for this house. How much down payment is necessary? Now, before I can start figuring out goal seek, or the right number for a cell, I can't have a formula in here. So I need to hand type a number. So I can just put down, I could put down 40,000. Now I've got a number hard coded in. How much down payment is necessary? Well, let's use goal seek. What if analysis, goal seek. Okay, I'm going to set cell, in this case C7. Notice little dollar signs there. That's an absolute reference. I'm going to set cell C7. Let's move this up here so I can see my labels. It's my monthly payment, and I want it to be negative 1190 by changing the down payment, and I'll click OK. There we go. So if I want to get this house, and I know what my loan is going to be, and I know that I want my monthly payment to be $1,190, that means I need to put in $48,522. What if I just can't afford to put down more than $40,000? Okay, so that's my down payment. Just can't do it. But I still want that payment to be $1,190. So how much? Let's see. How much house price can I afford? So instead of focusing on the down payment, I'm going to focus on the house price. Once again, I'll use goal seek. What if analysis, goal seek. In this case, I'm going to set the item price. Oh, sorry, wrong thing. I'm still going to set my monthly payment. Oops, I've got to fix this up here. Let's make sure I do this right here. I'm going to set cell, the cell that contains my monthly payment, to value 1190, negative 1190. There we go. And I'm going to do this by changing my house price cell. Click OK. Click OK. There we go. So I really can't afford to find a house for more than $191,000 if I've only got $40,000 for a down payment and I really want that 1190 monthly payment goal. And there we go. That's a little bit of payment calculations and using goal seek. So keep practicing with this and set up a bunch of scenarios for yourself and start to play around with the numbers so that you can quickly and easily figure out this information. And it's not just enough that you need to be able to plug in some numbers. I want you to be able to create this little calculator. Create this payment function calculator. which means you're going to have to enter in the formulas over and over and over again. So practice, practice. Okay, let's do a couple other things here. Get rid of that little box for a second. And let's say I am going to focus on this house here. Okay, house number 2. And I'll change my background colors. There we go. So I want to get this house, and now I want to really look carefully at my loan. And what I'm going to do is I'm going to create an amortization table. Amortization tables can be kind of intimidating the first time you see them. Some of you, I'm sure, have done them before, especially if you've taken the, I think you guys do them in CIS 131, and some of you may have even taken 125E, and I'm very certain you do them there. But they're a fantastic tool, and they're only as complicated as you make them out to be in your head. So let's try not to make them too complicated. An amortization table, by the way, is a detailed look at some loan payments. Just as a quick example, I'm going to jump over here to my browser, and I'm going to do a quick Google image search for an amortization table, and you'll see one. Here we go. There's one actually in Excel right there. Okay, so this is a amortization table, and might as well check this one out. Okay, so this is in Excel, and we're going to make something that looks kind of like this. We have some original loan data, and we've actually already got this information. We have our, they call it original principal. That's their loan amount, so we have a loan amount. And we know how long the loan is, 30 years. Okay, so this must be a mortgage. They have an annual interest rate, number of payments per year, and they've already calculated their payment. Now they're showing their payment to be a positive number, and that's kind of a nice way to go too. So we might actually switch ours around a little bit. So they're showing our payment as a positive number. And then the amortization table is right down here. And they're only showing us in this picture the first 6 months or so. So they start off with their original loan amount, and then as they make payments each time, part of their payment goes to interest, part goes to principal, and then the amount of the principal reduces the balance. So over time, the balance of their loan gets smaller and smaller and smaller. Now for a big house loan, it takes a long time for that house loan to get small, because as you can see, each month the loan only gets reduced by $170, $174. So if we could see this entire picture, 360 rows down, 360 payments, 360 months. Remember, this is a 30-year loan, monthly payments. Then the balance will finally zero out. So that's how you know that your amortization table is correct, is if the balance for the last payment is 0. Okay, so we want to make something like this. Let me jump back over to Excel. I'm going to work on that right down here. Let me just like my columns to be a little bit uniform. And let's see, I'm going to go ahead and put in, kind of like we saw in that other one there, I'll have my payment number. And I'm going to put in my payment, interest, principal, and balance. Okay. And let's see, the first payment will be we'll do payment 0, just like in that little picture, and we'll do 1, 2, and 3. I'm just going to do the first few here, and then I'll use autofill for the rest. Okay, now my payment, I'm not going to factor that in for payment 0. I'm just going to go ahead and plug in my original balance. Now I don't want to, my balance, by the way, is my loan amount. In this case, if I focus on house 2, it's going to be $151,478. I don't want to type that in by hand though. So I'm just going to put equals and then the cell that contains my original balance. There we go. The nice thing about this is if I change things, so if the house is back up to 200,000 and my down payment is, let's say, 36,000, as my loan amount changes, my monthly payment changes, my amortization table is also getting up to date. See, I'm using cell references as much as possible so that I don't have to keep retyping numbers in. Now payment 1 is where it starts to get interesting. My first payment is going to be equal to, let's see, now since my payment is expressed as a negative here, I'm going to use that absolute function the absolute version of my monthly payment. There we go. Now I want to go ahead and set this up now. I'm going to have lots of these formulas, lots of payments, okay? 180 of them to be in fact. And they're all going to reference the same cell. So whenever you have multiple formulas referencing the exact same cell, that cell should be absolute. So I'm going to select that cell. Technically I could just click anywhere in it here. I'm clicking on this cell reference to activate it. I'm going to press F4 on my keyboard. It's now absolute. And now when I press enter, there we go, positive number. I'll do some formatting in a little bit. Now the interest, okay? The amount of my payment that goes to interest is going to be equal to the amount of interest that I owe. So it's going to be my previous month balance. Actually, let me put this in parentheses. My previous month balance times my annual interest rate, absolute, divided by 12. And I'll do a closing parentheses. Okay? It's my previous month's balance times my monthly interest rate. Technically, I don't need these outer parentheses. It's just mostly a habit of mine. But if I take them out, no big deal. I do want these internal parentheses, though, because I want to make sure that I'm multiplying my outstanding balance times the monthly version of my interest rate. And also notice that I'm using the balance from my E12 cell. I'm not using the original balance from the house, and that's really the way it should be. I want to use, because this is going to be auto-filled downward, and my balance is going to change every month. So in my first payment, I want to refer to E12. In my next payment, I'm going to refer to E13, and then E14, and then E15. However, so that's a relative cell reference. However, all of these formulas are going to refer to C6 because that's where my main interest rate is. So C6 is going to be absolute, and I'll press enter. There we go. So I'm going to pay about $12.88 for a monthly payment. $670 is going to go to interest. Principal is going to be equal to my payment minus interest. There we go. So part goes to interest, part goes to principal. The balance is going to be equal to the previous month's balance minus the amount that went to principal. There we go. And I like this formatting here, so I'll use use that, and then I can just pop that down. So now we can really see what's going on here. So let's check this out. My loan started off at being $164,000, and then my first payment came up. I wrote out a check for $12.88. About half of that check went to cover interest charges, finance charges, cost of financing. The other half of that check paid down the principal of the loan. So instead of, I used to owe $164,000, now I owe $163,381, and I'm going to repeat this process over and over again. Fortunately, I've got this written in a way where I can select this row of numbers, and formulas really, and I can auto-fill down. And I can see that it's going to keep updating. My payments are staying the same because they're based off of this fixed loan. Okay, $12.88 is what I calculated as my payment. The amount of my payment that goes to interest gets smaller and smaller because the balance of my loan gets smaller and smaller, and my interest charges are based on my outstanding balance. As the balance gets smaller, the interest payments get smaller. And as the interest payment gets smaller, the amount that applies to principal gets bigger, which means my balance gets reduced even faster. So early on in the timeline of a loan, more of your payment goes to interest and less goes to principal. But as time goes on, you're going to see those numbers reverse. Now that I've got this going, I can autofill farther. Now check this out though. I'm going to actually select 2 rows here. I'm getting 2 rows of data because if I would have just select one row and autofill down, actually I got lucky here, it's working for me. Sometimes Excel wouldn't have gotten this, but the 3, 4, 5, 6, I just wanted to maintain that pattern. Sometimes when I write an amortization table, instead of doing payment numbers, I might actually put payment due dates, and then it's helpful to select multiple rows and drag down. But if I select multiple rows, I can start to drag down. And looking at my screen tip here, I'm looking for it to get to 180 because that's when I'll have 15 years of payments. So I'm going to drag this all the way down to 180. There it is. Let go. Excellent. So now let's check out this amortization table. Okay, so I start off owing $164,000. I make payments every month, and part of my payment goes to interest, part goes to principal, and the amount of the principal reduces my loan. After a while, in fact, let's go, there we go, it's payment 24, so this is after 2 years of payments. After 2 years of payments, I still owe almost $150,000 on that house loan. Remember, I started with owing 164 and I still owe 150 after 2 years. But as time goes by, the amount of principal is much bigger than the amount of interest. Okay? So about 90 months in, $400 of my payment is going to interest, and the bulk of it is going to pay down the actual loan amount, and it gets smaller and smaller. By the time I get to 180, which is my very last payment, practically the entire check that I write goes to paying off the debt, and finally we can see that at 180 payments, or 15 years of monthly payments, my balance is now 0. Now you notice I've got parentheses on here. Don't worry about that too much. That's because Excel is putting in a really specific number. If I were to show a bunch of decimals, we'd actually see at some point. Let me make this bigger. There we go. It's not truly a 0, but it's close enough to a 0, so that's why it's actually a negative 0.00000, a bunch of zeros, 409. But if I'm only showing a couple decimal places, that's perfectly fine. I'll just get rid of all those. Size that. There we go. So my payment, my mortgage is zeroed out and it's paid off. So now you own that property, 180 payments. And the amortization table we can use to figure out, gee, how much interest did I have to pay at this point and that point and so forth. Now check this out, another little aside here. If I select all of my principal numbers, if I sum up all of my principal, and you'll see this down here, it's right at the bottom of the recording, so it's a little bit tough, but I have my sum of $164,000. So the sum of all of my principal is $164,000, which, if you recall, is the amount of the loan. So the principal pays off the loan. If I add up all the interest charges, so if I select all my interest, and I go down to my sum, I see the sum is $67,907. That is my cost of financing. So the sum of all of the interest for each payment is your cost of financing, or your total finance cost. The sum of all your principal, of course, is paying off the actual loan amount. And of course, if I added up all of my payments together, I get to $231,000. And if I add the extra $36,000 for the down payment, I'll get my total cost. So the amortization table and the payment calculation really go hand in hand. Payment calculation gives you a quick summary of the information, and the amortization table gives you a lot more detail. I want you to practice this several times over and over. See if you can't write one of these for yourself from a blank Excel spreadsheet. Okay, so let's switch gears a little bit. I'm going to double click on this Sheet 1 tab, and I'm going to call it Loan Payment and Amortization. There we go. So now that sheet is very identifiable. And I'm going to do Control S to save. I'm going to go to Sheet 2. And I'll call Sheet 2 Saving for the Future. And I'm going to do something kind of similar. With my use of the payment function and amortization table, I created some labels and some scenarios for Excel to work with. I want to do something similar for saving for the future. For saving for the future, I'm going to go ahead and put in, let's see, I'll start here in cell A2, and I'll put in, let's see, let's do retirement age first. I'll do retirement or / goal age. I'll put in current age, years left, which is also called the time horizon. And I'm going to go ahead and put in rate of return. And let's see, let's go ahead and put in monthly investment amount. And we'll put future value. There we go. And we'll do person 1. Let's get that set up. Okay, so let's go ahead and create a future value calculator. And this could be used for saving for retirement or some other future goal. For instance, maybe your goal is to save $36,000 for a down payment on a house. That's a perfectly reasonable goal, and we could use that as one of our scenarios. Okay, so the retirement or goal age is basically, well, when do I want to achieve this thing? I'll go ahead and start off and I'll do retirement first. And I'm going to put down, I'll put 68 as the retirement age. Now for current age, I'm currently 38, so I can just plug in a 38. But if I want to get this updated automatically, I'm going to have Excel calculate my age very precisely. Okay, so that way it's always up to date. So instead of just typing in 38, I'm going to do equals today. There's a today function. In fact, let me just press enter here, which is going to put in the current date. So I'm recording this on April 1st, 2012, which is the Sunday before the first week of the term. So there's a formula to calculate or display today's date. But I'm going to tweak this. I'm going to take today and I'm going to subtract my birth date. Okay, so I'm going to put in a specific date using a date function, and my birth date is 1973, month 5, day 21. So I'm taking today's date and I'm subtracting an older date. Press enter. And that's looking weird. I get another number here. So I'm going to take this, I'm going to convert this into a comma style, basically number, and I get 14,195. What this is telling me is that there are 14,195 days in between that. So you can safely assume that the Sunday before the term started, I was 14,195 days old. But I want to get this in years. And I just realized I'm putting this in the wrong spot. I really want this to be down here under years left. Okay, so I'm going to say, well, I don't want it to be in days. I'm going to take this whole thing and close it in parentheses, and I'm going to divide by 365.25, which is the number of days per year. Don't forget leap year, so we just had a leap year. And I'll press enter. And now we can really see, all right, I'm 38.86. Okay? And since I'm incorporating my current age in with my years left calculation, I could delete this. But if you want to be able to change it easily, well, you want to be able to do that too. So I think what I'm going to do is instead of current age, I'll put in date of birth. And I'll put in 5/21/73. So now I have a date of birth up here. And now my years left can refer to my date of birth. So I'm going to edit this formula. Instead of subtracting the date, I will subtract the cell that contains my birth date. So I've modified this a bit. My years left is going to be today's date minus the cell that contains my date of birth. That's going to give me the days old that I am, and I'm going to divide by 365.25. And I'll press enter. There we go. So 5/21/73, 38.86. Now for the rate of return, I'm going to go ahead and plug in, I'll do 10%. Monthly investment amount, I'll put in $400. Now this should really be expressed as a negative, so let me go ahead and negative 400. I just typed a minus in there. And let's do a little bit of formatting. I'll format this as a currency. Counting format. I'll get rid of the decimals there. And let's do a little future value. Now for this one, I'm just going to type it up by hand. FV. The rate. Okay, so I'm going to take the cell that contains my annual rate. I'm going to divide it by 12 to get it in monthly terms because I'm making monthly investments. Comma. The number of periods. That's going to be the cell that contains the years left times 12. Because although I've got 38 years left, okay, and I just realized I've got a little typo in here. I don't have 38 years left. That's my current age. So I've just got these written out a little bit incorrectly. Let me take a moment to fix that, though. And press escape to get out of there. So this isn't really my years left. This is actually my my age. So if I want to get this to years left, I need to take my retirement age minus this. Easy enough to fix that. So for years left, I'm going to click on the cell that has my retirement goal age. So notice I'm modifying a formula. And I'll do a subtract. And I'll put all this in parentheses. There we go. That's a little bit better. So since my goal age is 68 and my date of birth is 5/21/73, my years left is 29.14. 29.14 is my time horizon. Let's get back to that future value now. My rate divided by 12, comma, the years left times 12, comma, the cell that contains my monthly payment or monthly investment. There we go. So this is my future value function. Rate divided by 12, number of years left times 12, basically number of months left, and then my monthly investment. All right, so here's what we can determine from this. If I start saving $400 a month and get an average 10% annual return, and I do that every month for the next 29.14 years, at the end of that 29.14 years, when I'm 68 years old, I'll have $825,710. That's what the future value calculation does for us. It helps to calculate the amount in the future based on consistent saving and a consistent interest rate. Now let's run this through with some other scenarios. All right, so I've got this set up. Let me do a little bit of formatting here. All right, and let's see. For person 2, let's say their goal age is 55. Person 3, let's say the goal age is 25 or something. Person 4 will do a goal age of 18. And person 5, I don't have a person 5 scenario. Let's just delete that one. Okay, let's do some different ages here. Let's say person 2 is a little bit younger than me. Let's say person 2 was born, how about May 1st, 1988. Okay. And I already can tell my years left is a little bit off here, so let's look things over. Nope, everything's good actually. I forgot we got the smaller time horizon. There we go. So we have someone in their early 20s, late 30s, early 20s. Now let's see, person 3 and 4, these are younger goal ages. So let's assume these are maybe a parent setting this up for a child. And let's say the date of birth for this one is May 1st. Let's see, we're 2012. Let's say this kid here is just a couple years old. So we'll do 2010. And let's say this child is 5/1-2012. So the kid is not even born yet, but they're due in a couple months. So that's some early planning there. Now the rate of returns, I'll go ahead and plug in 10% for all of those. Okay. And now we can start to look at some situations that we've got here. Of course, person 1 is taken care of. That's the one I did for myself here. Goal age of 68. If you hear that tapping, there's a bird outside my office window. Okay, just scared a bird away. All right, so I'm this first person here. Goal age of 68. Date of birth, 5/21/73. 29 years left to retirement. 10% return, $400 a month, $825,000 is the goal. Person 2 wants an earlier retirement age. They want to retire at 55, okay? But they've got some good things going for them. Particularly, they're younger, okay? So the younger you are, the easier it is to save. Or, I don't know, easier it is, but the less you have to save to get to the same goal. So they have just an extra couple years. Look at that. Just an extra couple years. By the way, we'd see cool things too. If I change my goal age from 68 to 70, check this out. When I press enter, that $825,000 jumps up to $1 million. Okay? So working another couple years might be prudent. Okay? I'll put it back to 68 though. Oops. 68. Okay, so person 2, they're in their early 20s. They want to retire at 55. We'll do those also at $400 a month. $1 million. Okay. Person 3 is younger. They're just a couple years old. They're just 2 years old. So the parents are setting this up for them. And maybe they don't want to put in $400 a month, but maybe if they just do $100 a month. Okay. So basically $100 a month. Kid's 2 years old. 23 years later, when they're 25, they've got an amount saved up of a little over 100 grand. Person 4 is not even born yet. They're going to be born in a month or so. And the parents want to have some kind of a college fund set up when the kid's 18. And they're going to maybe just put in about $60 a month. Okay. So $60 a month for 18 years. And that'll get them to about $36,000, assuming that 10% return. If we put this back up to 100, there we go. We're about 60 grand there. So those are our scenarios, and these are our future value calculations. And I'm using the date function to help us calculate the years left very accurately. So if I were to close this spreadsheet and then open it up tomorrow, all of these numbers are going to be slightly different because the years left for everybody is going to be reduced because it's based off of the current date. And we can easily determine how much they'll have at retirement or whatever their goal age was. Now we can start to figure out some other stuff. Let's say these parents over there for this newborn, future newborn, they really want to get to $100,000. So how much monthly investment do they need? Well, we can figure that kind of stuff out using data, what if analysis, goal seek. Okay, so if I set, let's put this down here, if I set future value to 100,000, by changing the monthly investment, there we go. They actually have to put away $165 a month in order to get to that $100,000 goal by the time the kid is 18, assuming 10% annual return. Okay, and we could do similar things for all of these scenarios. You know, what if I really want to have $1 million at age 68? Well, I can use that goal seek again. What if analysis? Goal seek. Okay, I'm going to set my future value to 1 million. 1 and 6 zeros by changing my monthly investment amount. Click OK. And now I've determined that I really need to be saving $484 a month if I want to get to that $1 million goal. And we can do this in a lot of different situations. What if I know I just can't save that much? What if it's going to be $350? Okay. And now let's say, you know what? I really want to retire at 68, but I know I can only save $350 a month, and I know I want more than that. So now I might determine, well, what's my retirement goal age then? So I can do what if analysis and goal seek. And I can set my future value, and I'll set it to 900,000 by changing my retirement goal age. And I'll click OK. So it's determined that I really can't retire until 70. If I do, that would get me to my $900,000 goal. All right, so keep playing around with this in a bunch of different situations. You've got a lot to work on. Let's see, I did all of this and it's just under an hour, about 55 minutes. But that doesn't mean you're going to master it in just an hour. This is simply the lecture for some skills that I want you to master. So you're going to have to open up Excel and you're going to have to do all of these over and over again. This is going to take hours of practice to get really quick, comfortable, and confident. Right? And that's what I want, quick, comfort, and confidence. So we've got our payment calculators to figure out monthly payments for items using fixed loans, an amortization table to get the details of those fixed loans, and future value calculators. Play around with that, have fun, and send me an email if you have any questions on things.